Another word problem from chapter 6.7 says, a biologist recorded a count of 360 bacteria present in a culture after 6 minutes and 900 bacteria present after 22 minutes. What is the initial population and how long did it take for the population to double? So again, we know our general formula is going to be A of t equals P, our initial, times e to the rate times time. So first we want to write down what we have at time 1, which is 6 minutes. Then we have A1, which is 360 bacteria. Then at T2, which is 22 minutes, then we have A2, which is 900 bacteria. And then from here we have two variables, we have 2 points. These are on a graph. So we can plug this in and write two different equations. So we have 360 equals, we don't know P, because that's what we're going to solve for, times e to the r times 6. And we can actually just write this as 6r, just to make it easier to see. And then we would do the same thing for the second one, equals p e to the 22r. So now, from here, what we can do is, since we want p, we can rewrite these equations. So in this case, p is going to be, and we divide by this term right here, p equals 360 divided by e to the 6r, which can also be written as 360 times e to the negative 6r, since it's on the bottom of the fraction. And in this case, p then is going to be 900 over e to the 22r, which can also be written as 900 times e to the negative 22r. Then we can set these functions equal to each other and solve for r. So we have 360 e to the negative 6r equals 900 e to the negative 22r. And there are many ways to solve this, but what we can do is divide both sides by 360. So then we get e to the negative 6r equals this 900 over 360, which can be simplified to 5 over 2, and then times e to the negative 22r. And then if we divide both sides by e to the negative 22r, or another way to say that would be multiply both sides by e to the 22r, then this goes away. And then we have e to the, and in this case we're going to be adding these exponents because they have the same base, and we can add them. So this becomes e to the 16r equals 5 over 2. Then we can take the ln of both sides, so we're left with 16r on the left, and then equals natural log of 5/2. So then r equals the natural log of 5/2 divided by 16. And this gives us approximately, if we plug it into the calculator, 0.0572, and that's rounded to 4 decimal places. So this is our r. And now that we have our r, we can plug it back into either of these equations to solve for p, our initial population. So let's use the 360 just because the numbers are smaller. So we have 360 equals p times e to the r that we solved for times 6. And this simplifies to 360 equals p times e to the, it's about 0.34361. And then if we plug this into the calculator, then we get p equals 255, and that's rounded to the nearest whole number. So that's our answer. And then it asks, how long did it take for the population to double? So we want twice the population, and then we have p times e to the, and then we have our r, 0.0572 times t. We want to know for what t is this expression true. So we can cancel the p's. Then we have 2 equals e to the r t. Take ln of both sides. Then we're left with this. So then t equals ln of 2 divided by 0.0572. And if we plug this into the calculator, we get about 12. So it took 12 minutes approximately 12 minutes for the population to double.